All right, hello everyone, and welcome to HackJPS 2024. All right, so let's get started. All right, so my name is Troy. You can see me up there. I am the operations manager on the robotics team here at JP Stevens, and me, Sai, and Naishad are co-founders of Grade Scout, and Ishan is a dev as well. If you guys want to introduce yourselves.
Hi, I'm Sai, and I'm the admin president of the JPS robotics team. I'm also one of the co-founders for Grade Scout.
Hi, I'm Nishad, and I'm a build president. I'm also a co-founder.
Hi, I'm Ishan. I'm not in robotics, but I'm an OG, so I'm still part of the team. So before we get started with the actual event, we'd like to thank our amazing sponsors who have made this event possible. We have Wolfram, VerbWire, Interview Cake, AOPS, Grade Scout, of course, Tleam, Desmos, and the Regal Eagles. And without the amazing support that these people have provided, we wouldn't have been able to host this event the way it is. So we'd like to give a great thanks to them.
We'd also like to give a thanks to our advisors and supporters who make this event possible. And so that includes Mr. Giuliano, Mr. Kazi, Mr. Hendriquez, Mr. Huffman, Mr. Carney, as well as the Edison Board of Ed and the JPS admin.
All right, so moving on to what is a hackathon. So a hackathon is an event where participants collaborate to solve challenges within a limited time frame, and it's often fast-paced, intensive, and competitive. Hackathons also often focus on specific themes or industries. Hackathons have diverse teams that build prototypes or solutions to solve real-world problems, and it encourages rapid prototyping and innovation. Access to resources like APIs and data sets are often provided by our sponsors. And projects are often judged based on innovation, usability, and impact. And hackathons foster collaboration, learning, and community impact, driving innovation and problem solving.
All right, so next we'll talk a bit about what a workshop is, because we'll be having a lot of workshops throughout the event. So basically a workshop is where it's an interactive learning session. It'll be facilitated by a group of experts or an organization that's coming in to present. And there's in-person or online formats, and since you guys are all here in person, you're fortunate to have a lot of in-person workshops, even from like NJIT and a lot of clubs here at JP. And yeah, they're also good for like networking if you want to get to know the people who are running the workshops, or just to meet other people who are interested in the same topics that the workshop is about.
So this is a map of our venue. Everything will be here in the cafeteria. The workshops will be over there on my right. Bathrooms are straight out and to the left. The main entrance is where you guys all came from, and that's where the lobby is too.
All right, so if you got to connect to the internet, we have a Wi-Fi up called HackJPS 2024. And if you're on a school device, after you connect to this Wi-Fi, you might need to reboot your device. Once you connect to this, you should be able to access all of the websites that you need.
I think on personal devices as well.
And please make sure you connect to, if you're using an Edison machine, please connect to this network and not like Edison Student or whatever, because there's a ton of websites like GitHub which have been specially allowed just for this event. So please connect to that one.
Once you connect to the network, just please make sure you reboot your device so that all the websites load in correctly.
All right, and then going over our schedule for today. So obviously the doors open at 9, and you guys are all here for our opening ceremony. From after the opening ceremony, there'll be some time where you guys can meet some other participants and start thinking about ideas. And then at 10:10, from 10:10 to 10:40, we'll be having the JPS Research Society come in. So they're going to have like an ideathon where you're going to be able to compete actually for the best ideas. And then around 11 o'clock, we're going to have the NJIT robotics team come in. So that's a collegiate, collegiate organization coming in for you guys. And we'll also be having the JPS Cyberhawks web dev division coming in at 11:50. For those of you who are not from JP, the Cyberhawks are our computer science club. And so they'll be coming in, and then at 12:20, we'll be having lunch. That's going to be Costco cheese pizza. They're fairly big slices. All of you guys who came in should have gotten a voucher for one slice, and then we're going to have a round for second slices, but that's going to be first come, first serve. So we can guarantee everyone's going to get at least one slice, which is fairly large. And then From 12:45 to 1:15, we're going to have another division of the Cyberhawks coming in. That's going to be the competitive programming division. So if you know anything about USICO or ACSL, those coding competitions, you'll be able to learn more about that. And then at 1:35 p.m., we're going to have our own JPS robotics team come in. We're going to actually have 3 simultaneous like sub workshops going on, where you'll be able to learn about each different sub team and do some interactive projects with them. And then 2:35, we'll be having actually some giveaways. So there's a lot of reasons to stay until the end, because we actually have a lot of different items we're able to give away. We have 2 Raspberry Pi zero units as well. So that's like a microprocessor. And we have some merch, some apparel and some merch from Desmos. So if you guys ever use Desmos, like for graphing and math class, we have stuff from Desmos. And we have some other stuff as well that we'll be giving away. And then, yeah, at 3 o'clock, we'll all be out of here.
All right, next we'll be moving on to our categories and prizes. So the first prize, the first category that we have is Best Overall Hack. And the point of this category is just the project that best encompasses the ideals that we mentioned before. Basically, it'll be considered for technical talent, practicality, creativity, as well as presentational and explanatory skills. And the prizes for this award are, the first prize gets the Wolfram Award, which is a Wolfram 1 professional 1-year subscription worth about $1,600 for each member on the team, as well as a $10 Amazon gift card for each member, an Interview Cake $50 full access license for each member, and one .xyz domain free for 1 year. The second prize gets the Wolfram Award, same as before, as well as the Interview Cake access license and the domain again. The third prize gets the Interview Cake voucher, as well as the .xyz domain. And the average value per team for this prize is about $4,600.
So moving on, we also have a category for Best Game Design. So game design is a fun way to learn more about programming. And so projects submitted to this category don't necessarily need to be like games made from the ground up. Like, for example, if you were to make a modification for a game that involves a significant amount of coding and it like really changes the gameplay, that's also fine. So the prizes are going to be the same Wolfram Award subscription, which is about $1,660, and for each member on the team, and the same Interview Cake $50 licenses for each member. And we also have one .xyz domain free for 1 year. That's for first place, and then for second place, yeah, those Interview Cake licenses will be given out. And the average value per team for this category is $3,450.
All right. So next up, we have the Best Youth Hack. And so we know there's a lot of middle schoolers around here. And so to make the playing field a little bit more even, we have teams that have more than half of the members as middle school students are eligible to compete in this category. And so in this category, the prize is Interview Cake full access license and one .xyz domain free for 1 year.
Our next category is the best use of artificial intelligence and machine learning. And so essentially, if you show that your project uses any kind of artificial intelligence or machine learning technology, you can be considered for this category. And it's not necessarily for projects that use AI for writing code. For example, if you use like Copilot, ChatGPT or something, that may not qualify you. And the idea is on integrating AI and machine learning, so using it in your projects to achieve your greater goal of the problem you're trying to solve. And the person that gets first place, or the team that gets first place, will get one Wolfram Award for a professional year license, which is worth $1,660, and each member will get that. And they'll also get an Interview Cake $50 full access license. Each member will get that. And the second place team will get the 1 year subscription for each member from Wolfram, and also the Interview Cake $50 access license. And the average value per team is $6,840.
All right, next we have the best use of AI and VerbWire API. So VerbWire is one of our sponsors. So the description of this award is that it's the best team, the team that best uses the AI in conjunction with the VerbWire API in building applications. And more information can be found on VerbWire's website. So feel free to use magicpilot.ai, which is a tool made by VerbWire to build Web3 programs using AI. And the prizes for this category are up to 5 different teams which can win this category. All 5 members of each winning team receives $45 in WordWire premium API credit, which can be used to build other projects. And the average value per team for this prize is about $180.
Yeah, so next up is the most innovative use of VerbWire API. And so this goes hand in hand with the last category. And it goes to the best overall projects which use the VerbWire API. And so all members of each winning team get $45 of VerbWire premium API credit, which is an $180 average value per team.
Okay, so next we'll be talking about our lab simulation category. So for those of you who were here last year, you may remember that our theme that year was education, and we had a lab simulation category. We actually like this category so much because it gives a lot of flexibility for your projects. Even if you're a beginner who only knows how to do Scratch, you can still do a lab simulation in Scratch. Or if you're relatively advanced, you can even include like physics concepts and stuff within like a more advanced programming environment. Sorry about that. Yeah, so basically this can be about any scientific topic that you're familiar with from your school's science curriculum. And the idea is you have to be able to make, like, I'm sure all of you guys have used like a Pivot Lab or a Gizmo or something like that to learn a science topic online before. And you're basically trying to create something like that. And yeah, so we really are excited to see what you have for this category. The prizes are going to be that Wolfram Award subscription, which is $1660 per year for each member. There's also a $10 Amazon gift card for each member for first place, and the Interview Cake $50 subscription as well for each member, and one .xyz domain for free for 1 year. And then for second place for this category, we also have $10 Amazon gift cards for each member, as well as Interview Cake, $50 full access licenses for each member, and one .xyz domain free for 1 year. The average value for each team in this category is $3,570.
And our next category is for Best Industry Hack. And this is essentially for any project that provides a service or convenience to professionals or customers within a specific industry. And those industries can be anything, including healthcare, education, finance, and much more. Except the thing is the project cannot be too generic. It must be specifically made to be used as a tool of service within the real-world industry. So it can't just be like a toy or a prototype or something small. It has to be something that you can actually use if it were to be implemented fully into production. And the prizes you get for this, the first place team will get the Wolfram Award, the same $1,660 for each member, and you'll also get a $10 Amazon gift card for each member, along with the Interview Cake $50 license for each member, and the XYZ domain. Additionally, the second team to win this will get the Wolfram Award, an Interview Cake license, and the XYZ domain. And the average value for each team is $6,870 for any team that wins this.
All right, so next up we have the Public Choice Award, which is pretty common among a lot of hackathons. So after submissions, all registrants will be able to vote for their favorite project on DevPost, and the project with the most votes will be eligible for will win the Public Choice Award. The prizes for this category are a $25 Art of Problem Solving coupon for each team member, and the average value per team is about $100.
Okay, so some general guidelines so we have the specific rules on the DevPost page, by the way, if you want to check those out later, but just some general guidelines for now. All code must be written during the time frame of the event. So if you have projects from like a previous hackathon or that you started like last week or something, those probably wouldn't be allowed. Any attempts to exploit the network infrastructure will result in immediate dismissal and disqualification. The JP Tech department over here worked really, really hard to set up this for you guys. So please try not to don't try and take advantage of that. And then copying another team's project or submitting an external application without original modifications will also result in disqualification. So basically just don't plagiarize. And this is a team event, so 4 people can do more work in 36 hours than 1 person can. We highly recommend you try to form a team, even if you came here alone. It'll be a great experience for all of you guys. And here's our generative AI policy as well. So this is new for this year in recognition of the fact that, of course, generative AI has become very, very popular, and we think it's going to be a fundamental aspect of developing in the future. So we don't want to say that, no, you can't use ChatGPT, you can't use Gemini, you can't use Copilot, because in reality, when you guys are in the industry, you guys are probably going to be using these things, and your coworkers are going to be using these things. So our policy is that any use of generative AI is allowed, but must be clearly stated in the project submission page. Participants should give credit to the specific models or tools they used, and if possible, state how they were used. And this will not count against the value of the project. And however, participants must still be able to demonstrate a clear understanding of their own code, especially in the video part of the submission. If you guys aren't familiar, by the way, there is a video requirement. You can see that on the dev post page when you guys are working on submitting. And you should not use any form of generative AI for the video or for writing the written part of the project submission page. So you may use it for your project, but not for the submission part where you have to write about your project and speak about it.
You guys should have all signed up at the dev post. So check hackjps-2024.devpost.com for all of the other info.
Yeah, so all of our rules, all of even the schedules on there, a lot of other information's on there as well. And of course, our regular website is hackjps.org. But for right now, I think the dev post is probably more relevant for you guys. All right. You guys got it. So.
All right, yep. Have fun. Make sure that's the most important thing. And then you guys got this. Submissions close tomorrow at 6 p.m. EST.
The workshops are going to be over there, but they aren't starting yet. They'll be in a few minutes.
The first one is at 10:10. They're going to be sold.
Yeah.
So
Oh yeah, snacks will be sold in the back over there by the.
Don't worry, lunch is
flip table.
included. You
Yeah.
get the one.
lunch is free. The snacks are for sale.
Yeah.
For sale.
I just want to say that the most important thing about this is not winning. It's about the experiences and what you learn from this. So don't try to do this from the mindset of trying to win. Think about what you can learn from this experience. And yeah, remember all projects are due by 6 p.m. tomorrow. We're going to have a week of judging, and then we should get back to you by about next week to announce the winners. You guys can start, so get at it. Knock yourselves out.
Check, check. You good? All right then. Good afternoon, everyone. My name is Yudhishpa Sandalkumar. Next to me, we have I'm from the JPS Research Society. Next to us, we have one of our outreach advisors, Floria Nehe. And today we're here to just present all of you a little bit about research, the importance of it, as well as for all of you to get some ideas on how you can make some of your own research projects and develop good research questions. So welcome to this Ideathon. So basically today you're going to learn how to explore innovative and research ideas in the field of computer science and AI. You'll also be able to figure out how to sort of solve gaps of knowledge when it comes to certain topics that we are already existing and pretty well known. And we'll also learn how to develop feasible and impactful solutions on how to address these problems. And finally, you'll be able to showcase your expertise and passion for computer science and artificial intelligence, which would be useful if that's a major that you're looking to pursue when you move into college. So we're going to focus on multiple topics here today. And so those would be machine learning and deep learning, computational sciences, mathematical reasoning, functional programming, visual and data visualization. And at the end, you'll all be able to make your own research questions on any computer science related topic that you want. So there's a lot of very interdisciplinary areas within research, and in this Ideathon, you'll be able to clearly define a problem or challenge that you want to address through your research idea, and you also learn how to conduct background research to gain insights into existing work and identify any gaps for any opportunities or knowledge, and finally you'll be able to identify any key objectives that you want to research and any outcomes that you wish to achieve at the end. So when it comes to making a research idea and conducting a research project, there's multiple techniques that you need. First off, you need to be able to brainstorm what exactly you want to research, and you basically want to keep yourself pretty free in this. You don't want to restrict yourself saying, okay, I want to focus on a specific topic within the field. First, you want to keep yourself general, and then start getting more specific as you go through. And second off, you want to do some mind mapping. You can create a visual representation. If you do it in your head, that's great. I personally would suggest that you use maybe like Google Sheets, Google Drawing, Google Docs, or any of those softwares that allow you to explore different aspects and basically connect everything back. And you also need to figure out some analogies. You want to figure out what your inspiration is for your research project. And you want to be able to draw your inspiration from any unrelated fields or domains and apply their concepts to your research problem. And you also want to use some reverse thinking. So really you want to challenge any conventional assumptions and envision the opposite scenario to simulate any fresh perspectives so that you have the best research possible. So in this workshop, the objectives is basically understand what is the importance of a research question. You want to be able to recognize any good question traits, and you want to be able to practice creating research questions, all of which we'll be doing here today. So first off, we need to understand what is the importance of research on society. So first, I want to ask all of you, what do y'all think is an impact of well-defined questions on research? Anyone have an answer? You had your hand raised? Yes, to help people understand a topic. That's definitely a great answer. Anyone else? Yes. To solve an issue, exactly. So through a well-defined research question, like I mentioned before, you want to be able to figure out how you're going to fill in a gap of knowledge, and in order to provide information that is either novel or builds upon what people already know. So you can look at other research projects, figure out what they're missing, and then develop your own research project from there. And in order to have a very good research question, you need it to be clear, focused, and feasible. So, for example, as high school students, we might not have access to probably the most advanced labs known to mankind in order to be able to figure out, maybe gather data, be able to process that data, and be able to put certain experiments through it. But you need to first understand what you have available to you, and then from there take your research question and develop that. And you want it to be focused as well. You don't want to make it too broad, otherwise you're going to end up researching way too much, and you won't be able to get your project done at the end. All right, so now we have some examples with some research questions. We're going to pass it to Floria.
Okay, so since building your question is the first step into starting your research project, you want to make sure you have a strong understanding and a solid foundation to build the rest of your project on. So the first example question is, are AI and machine learning the same thing? So you guys can raise your hands, just suggest if you think this might be a good topic to have your project on, or maybe a poor topic. Okay. So everyone who thinks this is a good topic, raise your hand. Okay, everyone who thinks it's a poor topic, raise your hand. Okay, so I see you guys leaning more on the poorer side, and I would say that's a great analysis. This is a close-ended question. It can have such a simple response. You want to make sure that when you're doing your research, it doesn't end in one direction. You want to make sure you can delve a little bit further. It allows for exploration, and as you're researching, as you're going down, there's more depth and value that can be added to the topic. So the next question, how can reinforcement learning algorithms improve path planning for autonomous vehicles in congested traffic environments? Who thinks this is a good research project idea or topic? Okay, raise your hands a little bit higher. Okay, who thinks this is a poor topic? Okay, so everyone decided that it was on the better side, and yes, you're right. It's focused, it's feasible, and it is very relevant, right? So once again, you want to make sure you're not just running at any question you find first. You want to look at the question, see if there's value to it, and maybe research around to begin with. See if there's something that you can discover if you're interested in it, first of all. Next. Can I make a robot that does my groceries? Is this a good research topic? Just raise your hands if you think so. Okay, is this a bad research topic then? Okay, good. So this was meant as a little bit of a trick, but you guys got it. Even though it's fun, even though you may be able to run a little bit of like experiments with it, might be engaging, you still want to make sure that the basis of your topic is somehow like rooted in an academic field. You don't want to have your projects going into different tangents and going into things that, you know, might be too advanced or not really relevant, again, to what you're doing. Another example. How does the choice of programming languages affect the performance and scalability of large-scale distributed systems? Is this a good research topic? Okay. Anyone think it's a poor research topic? Okay, would you like to explain?
Yeah, what happens if, what if there are no
Okay, yeah. So basically, this question is a clear and focused research topic, right? So obviously you guys know how to identify clear, unclear, things that might go far too deep, things that are a little bit too shallow. So you want to make sure that you're looking for all these things when you're starting your question. If you follow a bad question, you go down that path, it can be very frustrating because the rest of your project is going to be based on the question. So you want to make sure you're starting off strong, you have a good foundation, And once again, it has to be very clear and focused. You don't want it to be too grand of a topic. That's going to be too many things for you to cover. And when you're making it specific, make sure it's still not closed-ended. It can't be answered by anyone just by a simple yes, no, maybe, I think so, or an experiment said this. Okay, next we're going to go into current areas of research gaps. So these could be any topics or any areas that you guys should be finding questions in. So one is human-computer interaction. And that is essentially designing effective and user-friendly interfaces. A lot of things on the internet can be very complex, so you want to make sure that you're leaning on the side of things that are more comfortable, more familiar to humans. Next, the Internet of Things, which is enhancing security, connectivity, and data management. You have quantum computing, developing algorithms in practical applications. Edge computing, addressing latency, security, and privacy concerns. Natural language processing, advancing machine understanding of languages. Ethical AI, mitigating biases and ensuring responsible development. And lastly, augmented/virtual reality, which is improving rendering techniques and user experiences, right? So I feel that just by reading off this list, you all can agree that these are some topics that need to be delved a little bit deeper into. We see it in our everyday lives, whether that's through ChatGPT or whatnot. So if any of these topics interest you, you can research your own research gaps as well, but they're an excellent way to start and to find questions that you would like to explore further. So now I'd have you guys discuss, whether it's in your teams or you can break up into groups of 2, just what areas, it could be from the slide or something that you just came up with, what areas of research do you think have a little bit of gap that you can dive into, and make a brief question. Remember to follow the steps that we gave and just discuss for maybe 2 or 3 minutes and come up with a question that you think would be great for your research project. Okay, so does everyone have a question, or do you need like 2 to 3 more minutes? Just raise your hand if you need more time, or if you... Okay, so I'll give you guys 2 more minutes. Just finalize a question. Okay, so at this point, I think everyone should have generated a question by now. So if you have one that's ready to go, just raise your hand. Yeah.
How come we can't find it? How come everyone can't find it? What happens if we can't like join? We like give up or something. We still
What did he say? Yeah.
Can you speak up? Raise your voice. Speak up.
yeah. How come like why can't? What happens if we get pushed out of every team?
I would suggest just find like one other person, just find a partner and just discuss the question with them. So it could be someone next to you. Okay, so everyone who has a question, just raise your hand and one by one you guys can come up and just share your idea. Okay, are you guys ready to come up? Okay. I'm gonna sit over there.
Okay. So basically, right here. No, speak up. More louder. Okay. So what our team proposed was we thought about can AI think like a human can. So like if you like search up in ChatGPT, it'll give you a prompt answer like immediately, because it doesn't actually think anything. It just like finds the best, most probable answer. What we thought was how can like an AI actually think like a human can? So like rather than giving the answer like immediately, it can give the answer like it can wait 20 minutes. Think like a human can, like take time, analyze, research something, and then actually then give like a more accurate answer. That's thank you.
Yeah, that's good. Definitely great. I think you got straight to the point.
Yeah, so that would be a great example of a question that's clear cut. They know what they want to research, and it's something that's going to be new as well. Anyone else have an idea they would like to share? All right, anyone? Do you guys want to share? You can sit down and share it if you want. It's fine, you can share it. We're gonna say it's good either way.
So our question is, can AI develop more emotions? So if we like tell AI a situation, like, okay, this happened or that happened, can AI support us by like, okay, that sounds good or that sounds bad, and then can it like even solve our problems based on how we're feeling?
Yeah, that's perfectly fine. I mean, while that is definitely a yes or no question, it's still pretty good because in the end, you can still develop some form of procedure on how you're going to research that, figure out how you're going to get data, and exactly what you're going to do in order to actually solve that problem at the end. So even though it's a yes or no question, that's still pretty good.
Yeah, so even if you have a closed-ended question, you can always find a way to make it open, like with your guys' question. If you just add a little bit more, like shift the viewpoint, you can always find a way to make it a little bit more deeper or find more ways to delve into that topic. Is there anyone else who wants to share? We can take one last group. Okay. So if nobody else wants to go, then that was it for our Ideathon presentation. I hope you guys are interested and learned a little bit more about how to start your research project and just things that you should keep an eye out for.
All right, then. So just to cap it off, thank you all for listening to our presentation. I hope you all enjoyed it and learned something from today. Just so all of you know, there are a lot of research opportunities both in school and out of school. Okay. So there's always great research opportunities both in school and out of school. So if you're interested, always make sure to explore. And just for a little outreach for our own club, we're the J.P. Stevens Research Society. So next school year, please be on the lookout for us during the club fair. And if you're interested to join, please feel free to do so. Thank you all for attending, and that's it for our presentation.
everyone. My name is John. I'm with the NJIT Robotics Club. I am also the president club and a hello? Oh, okay. And I'm also I'm a fourth-year computer engineer at NJIT. Ooh, okay. Sri, would you like to introduce yourself?
Hi everyone, my name is Sri. I was a part of the club. I graduated back in 2021, and now I'm also part of NJIT, where I was the vice president of last season.
All right, thank you. Today, our workshop is going to be on very basics on data science, just to get you introduced to the topic if you don't already know. So I'm sorry if you're looking for more advanced topics on data science, but this will just be more targeted towards beginners. And we'll also have a live coding demo and just go over everything general ideas and topics about.
That way a little bit.
Okay, right here. Right. Just some general ideas and topics about data science. Next slide.
That's where the antennas are.
All right. So what is exactly data science? Let's click. So it's going to be more on the combination of both your mathematics, your programming skills, and just general data visualization. So think more so, where is the attendance? Right here? I can't move around, right?
If it keeps doing that, I'll have to try and get you another microphone.
Okay. This is more so on the very basic statistics, running your programming and coding skills, and getting your graphs and plots. So given any data set, you should be able to perform calculations, make some plots and graphs, and of course draw conclusions with those graphs. And then after you get those conclusions, you're going to act on those conclusions. And this is like your very basics into your fundamental theory behind machine learning and artificial intelligence. Because at the end of the day, machine learning will be more focusing on making those algorithms and training them on random data sets, whereas data science is going to be covering more so on the actual probability statistics behind those data sets and narrowing down your data sets to feed into your machine learning algorithms. All right, so we're going to go more towards the applications for data science. So one of the applications for data science is, of course, making those conclusions and determining characteristics from those data sets. So for example, this one article from 2012 all the way back then, where Target was able to determine whether a customer of themselves was pregnant based on their search habits on their Target website and how they shop. This, of course, triggered more privacy issues and data collecting issues. But this is kind of like the very basics of where data science comes into play, where we can determine statistics, conclusions from whatever data set you gather. So of course, with data science, you're going to be able to make appropriate business decisions, determine characteristics of a person, and where this applies to machine learning, you'll be able to determine the core features and patterns within like recognizing digits, and of course, applying it towards natural language processors, where we able to determine if a certain sentence or word has certain sentiments and feelings. But of course, we can also apply it to elsewhere. So given who here plays Valorant, raise your hand. Nobody plays Valorant. Come on. All right, here we go. A couple hands right here. This is this is like your actual core example that you can relate to. If you can gather all the data, whether what time of day you play, how well you played, and how well you performed, you'll be able to determine the optimal time to play and get where you have your peak performance in Valorant. So how can you use this? So how you would actually apply data science, you will first start off with your data set. You'll run some algorithms, make some graphs, and then determine some features in your data. So whether those features are determining the correlations between multiple variables, and then you'll be able to apply them to make predictions and models, and of course apply them to your machine learning algorithms. So here are a couple of data set examples. So if you have a data set of all the Apple stock prices throughout the day, you'll be able to create some sort of predictor model. Although stocks are a little bit hard to predict, which is why we try to develop at least somewhat accurate and somewhat predictable model for stocks. Okay. Of course, you can also have data on Twitch streamers to determine what is the best optimal time to gain the most subscribers in a given month, and of course, what kind of category you should be streaming on. this is you.
All right, so the data set that we're going to be Hello? Hello? Okay, cool. So the data set. Hello? Okay. Okay, that's all good. So the data set that we're going to be doing it on is actually a diabetes data set. So given multiple factors on the human body, we'll be able to try to predict or try to tell whether a person has diabetes or not. However, the part that we're going to be focusing on is the part right before that, is identifying which characteristics of the actual data set or which parameters will be important in making that determination. So for example, you could look at like blood sugar levels, right? Which, take a wild guess, is probably pretty important. But let's say you have something like body weight, right? How much is this really a factor, or is something that we will have to figure out using the data set and something called a t-test. So a t-test, so how many of you guys, hello? Hello? Okay. How many of you guys, I'm going to fling this mic across the room. So how many of you guys have taken some sort of statistics class before? AP Stats? Okay. This mic is worse than my statistics skills. Okay, so pretty much t-test is used to make an inference. So I have not moved. Is it fine or?
Just start belting and turn it off and start using your diaphragm.
Yelling. Okay, bet, let's go. All right, so a t-test is, yeah, you want, I'll keep this. So a t-test is an inferential statistics test, and basically what it lets us do is tell us if there is a significant difference in the two samples that you're trying to compare. So if there's a sample of people who don't have diabetes, and you have a sample of people who do, you'll want to figure out pretty much what is that difference and how confident you can be that that statistic actually does make a difference, right? So there's two examples. So you can have a one sample t-test. So if you have like the average of the population, you'd use a one sample t-test. Or if you have two, you can compare two different samples and see how they differ from each other. Next slide. So with that, we'll go into the live coding demo. Based on how the network's been going, I can't promise Google Colab will work, but we'll try it and see what happens. It's on your computer or mine? Just open a live Colab on yours. A live Colab? Okay. Yeah. Just open Colab and then we'll do it as we did. There's a new notebook? Yeah. Don't you need a data set or no? Yes. Okay. I will put up the data set. The data set link is on there, right? Or no? Oh, no, it's not on there. You probably don't want to pull up Discord, right? Okay, I'll put it on the last slide. It's trying to connect.
Oh my gosh.
Oh wow, I'm on mic. That's crazy. I don't want to put them on Kaggle because that's kind of annoying. Oh, okay, I'm back.
Yeah, we're pulling up the stuff. That's the one you want me to pull?
Let me go ask. Hold on. That's not good. This is not it.
that works? Yes. That was me opening up a different Colab.
Was that me trying to do the
Yeah.
the data scraping for? That's actually fire.
Okay, you got a fresh Colab now.
All right, so originally we were gonna have you guys pull up the data set from Kaggle, but it turns out Kaggle is blocked. We love JP for this. But pretty much we have uploaded the data set, or Troy should be uploading the data set onto the Discord server. So if you guys want to follow along, you guys can just pull it up from there. Is everyone on their school MacBooks? Some, oh, it's unblocked? Nice. Okay, cool. All right, so in that case, we can actually get started.
How are you going to do it this time?
Yeah. Oh, can you download the file from Discord? You might want to.
Is it up already on Discord?
Nope. Or maybe it's an update. Oh, it's an update, yeah.
Okay. Oh no, it's light mode. I'm going to get called out.
All right, can we all call out John for being on light mode real quick?
Let's use recent downloads.
All right, cool. You can just upload it to this. Just drag it in.
Whoa.
No, cancel. Click on this.
Click on this.
Yeah. Wait, give it a sec. Yeah. I'll be there.
Will
Trust.
be there?
Yeah.
Okay, I'll trust you. Is that not it? Sample data?
No, it won't be in sample data.
There you go.
Okay. So the first thing you'll want to do is open a Colab or editor of your choice. You know, if you have Jupyter Notebooks, you can use that. If you want to use in VS Code, you can create a Python notebook. You can do that as well. And then from there, there are a few packages that you'll want to install. Some of them already come pre-installed with Colab. Some of them you'll want to install on your own. So the one that we'll install is stats models. So this is where the t-test will come from, and it will basically save you a lot of the time of you looking up the t-table, finding the value in there, and bringing it back. So if we just do exclamation mark, pip install, and then the name of the package, it will let you install whatever it is that you want.
If it goes down again, it's the reception in here.
Okay. Oh, okay, this seems better. Cool, thank you. Nope, it's down.
It's the reception in this area of the room.
Okay, no, that's all good. So you can do pip install and the name of your package. So ours is stats models, and we'll import the rest of the packages that we need. So there's import NumPy, and you can actually do, if you've never used Python before, you can actually do using NumPy as certain things. So you can give it like sort of like a nickname. So we'll do as NP. Hello. Okay. No. Okay. You can do as NP, and then there are a couple other packages that we'll use. So I'll just type them out, and then you guys can copy them down as I do. There you go. That's fine. Spy lot. spell stats. Okay. Cool. So these are the packages that we'll be using, right? Some of these we'll only use once. So like, for example, matplotlib, if you've never heard of, is used for visualizations. So if you have like a certain graph you want to make, you can use that. And then pandas is used for data frames, so which is essentially like an Excel sheet, but in code. So that's always pretty cool. NumPy, it just makes things a whole lot faster. So it's written in C, and if you don't know what C is, it's basically a really ugly programming language to write in, but when you run it, it's actually super, super fast. So it's actually worth using, and it's worth learning if you haven't tried yet. And then stats models, we explained earlier, is where our t-test comes from, and then SciPy stats is another package that you can also use for that. So the first thing you want to do is, if you haven't already, download the data set. It should be like 24 kilobytes-ish. It's really small, but it will perfectly work for what we're trying to do here. And I believe it's uploaded onto updates in the Discord server. So if it's not there, you can yell at Troy, but I think it's there. And then what we want to do is we want to create a data frame. So we can do df equals, John, do you want to type? Okay. Cool. So the first thing we'll want to do is create a data frame. And the way you do that is using pandas, right? Data frame comes from pandas, so we have to tell it where to find the, okay. So, okay. So yeah, once you read the CSV into the data frame, I think this spot was better. Once you read the data set into the data frame, you'll be able to do len df. And basically what that does is find the length of the data frame, and you should see the exact same number that we have up here, 768. So, okay, good. I'll tell you when to type the next one. No, you're good, you're good. Okay, so from there, we then can print the data frame's dtypes, which is the actual parameters that are in your data set. So each of the columns represents some value or some parameter that you could use if you were training a machine learning model. And so for example here, we have pregnancies, glucose, blood pressure, skin thickness, and so on, right? And there are a total of 9 of them, right? And the one that's labeled outcome is basically what tells you if the person has diabetes or not. So after you run these two basically tell you if your pandas work properly or not, and if you actually have the data set loaded up. And from there, what we'll be able to do is do basic statistics, right? Find the average and figure out like what type of data that we have in our thing. So what you'll also notice is on the side of each of those parameters, you will see the data type of the value in there, right? So for example, number of pregnancies, you better hope it's an integer because you can't really have 0.5 of pregnancy, that doesn't really make sense. And a couple of other things like BMI and diabetes pedigree function, things like that. Some of them are floats and some of them are integers. And that is just the way the data set was given. If you were making your own data set, you could decide how accurate you want certain things to be. For example, BMI could very easily be with a decimal point if you really wanted to. So from there, we can print out like things like the average or the number of people in the data set that have diabetes and the number that don't. So in this case, we have like 500, we have like 500 people in the data set that had diabetes and that didn't have diabetes, and 268 people that did. So while the data set itself is what we'd call unbalanced, that's completely okay, and for what we're gonna do with the statistics, it actually won't make too much of a difference, but if you're training your own model, it actually will make a pretty big difference if you have a really biased data set. Yeah. So from there, what we'll want to do is check if there are any null values in our data set, right? If you have any zeros or null values, that's pretty bad because then it's going to sort of throw off your data set because you have a bunch of values which were technically unknown, but they've just replaced it with 0, right? So your average would be super low or it would technically be completely incorrect. you want to just copy paste it?
Are you sending this to me?
This, oh, okay. Should I just DM it to you? Or should I just send in this? I'll just send it in general.
Okay.
All right, so all of the replacements I've just sent in general. I don't want to spend too much time just sitting here typing it out, but pretty much what you can do is you can replace any values that were 0, right? Or replace any of those values that were technically unknown and have it not skew up your data set by replacing with NAND. Yeah. You can copy paste and send anything else you need to. Yeah. So from there, if we actually check which values are null, because we replace some of them with null, you'll see a bunch of these columns actually have true. So everywhere you actually see that, those values, for example, 0 blood pressure isn't really a thing, or I sure hope not, and like 0 insulin and things like that aren't really practical values, right? So what we do is we replace those zeros with null, and then we can replace those again with some value that we pick. So in this case, a simple one that you can use is just the average of those columns. And if you really wanted to be more complicated or more accurate, you can technically use the other parameters from each of those rows to predict what you want those values to be. Very good. So there are a lot of complicated things you can do in data science, and some of them are really cool. They'll make your data set more accurate, even though you might have not had that information collected in the first place. But in this case, what we'll do is we'll just have it replace it with the mean. So, or I guess this time the median. So you can also pick the mean, that's completely fine. The choice is yours in this case. And once we do that, we can then create a correlation table. So here we see a big table, but what you want to think is, what do these values actually mean? So every variable has been printed or plotted against itself and every other variable in the data set. So if you do that, you'll see down the diagonal from the top left to the bottom right, you'll see all of them are 1, right? So if you were to plot like an XY graph of each of these variables, you want to imagine that all of them will be perfectly correlated, right? But on the other hand, you'll see some of these are like close to 0, which means each variable plotted against each other, those variables make no sense, right? You cannot use one of them to predict the other. So if you're creating a regression model or trying to predict values of one variable in terms of the other, those are not good ones to try. Those are practically completely random against each other, and they will not be of any use. However, if you look at, let's say, glucose, an outcome, you'll see it's at 0.4927, right? Which is, if it was 1, they are perfectly correlated, right? And if it's 0, they're pretty much random. And if they're -1, it means they're inversely correlated. So as one increases, the other one will decrease. And in this case, at 0.5, it's not great, but it's better than anything else we could possibly pick from this table, right? So. You can do this one.
What? Stats?
Yeah, you can, actually no, just go do this. Yeah. So, with this, right, there are a lot of different graphs that you can make that will help you understand your data set more, but for the sake of time, we'll skip through those and get to the actual cool stuff. So here we can see a blood pressure graph, right? You can see, like, based on what readings were collected, where people's blood pressures fell. And you'll see there are a couple of spikes here and there, right? No data set is perfect. You shouldn't expect to see like a perfectly normal distribution anywhere. But in this case, we don't know which ones were people with diabetes and which ones weren't, right? And in this case, what we want to try and find out is blood pressure a good indicator of whether someone has diabetes or not? So if we go down to the t-test, do this one. Yeah, so the question that we're asking, and I'll read this word for word because I made it really nice. So, is the blood pressure of people without diabetes in this sample significantly different than the blood pressure of the population, right? And to put this more simply, it pretty much means the people without diabetes, is their blood pressure different from the average of everyone, right? And in this case, hopefully the answer is no, because if the answer is no, then we know that that is the common, or like what is expected value, and then we can figure out which ones are the anomalies or the people with diabetes. So, yeah, so if we type that out, you'll see the values you get is you get a statistic of like 0.419 and a p-value. And the thing you want to remember is the p-value is the important part, right? So based on what p-value you get, you can either accept what we'd call the null hypothesis or reject it. So I will send this in the Discord too. Whoa.
Because they're just hashtags.
Yeah. No, it's this one. Okay. Oh. Yeah. So, you see the question that we asked, right? And we decide two hypotheses. So we'll either say it is the same, right? Or it's significantly different, or pretty different. And what we do is we set an alpha. And what alpha is it's pretty much just our acceptance criteria. So we're willing to be up to 1% wrong. So hopefully we are, based on this test, we believe that we are 99% accurate with the hypothesis that we make. So in this case, with a p-value of 0.88, we see that it is not within that 1%. So if it's within 1%, you should expect it to be like 0.995 or 0.005. And because it is not within those values, we in fact cannot accept the hypothesis, and we cannot reject the null hypothesis. So the English is really weird when it comes down to it, but the way it works is you can either accept H naught, or you can reject it, right? So the alternative is like, you can't, how can you perfectly put this? It's like, you're not guaranteed to know what the perfect answer is, but you can reject what it is. Oh, hi, Rushi. You want to say hi to Rushi?
Hello.
So this is Rushi. He's currently the VP of the Robotics Club, and he just got here. So yeah, that is how this works. And pretty much what we're doing is we're comparing it to the population. So now if we took people, if we took people who did have diabetes, we can see if this is statistically different or not.
Oh, you got take one, right?
Yeah.
Oh, no, you got a different one?
Yeah, I'll send you this one. So the next test that we'll do, right, to see if this works or not, is the blood pressure of people with diabetes significantly different than the blood pressure of people without diabetes, right? And hopefully, if everything goes right, the answer should be yes, right? So if we run this, so we'll set up our two hypotheses, and we'll see that it's either the same or it's different, right? Those are our two hypotheses, and we'll see what we can do. And again, we'll set our alpha to 0.01, which is like 1%. So hopefully we're 99% correct. And when we run this, we'll see that our p-value is like in the 10 to the negative 6 range, right? So that is significantly smaller than what we expected it to be, right? So in that case, we can actually reject the null hypothesis. So H0, we can reject H0, and we can confirm that H1 is true, right? So the blood pressure of people with diabetes is significantly different. So the thing that you want to imagine with this is that if you're trying to train a machine learning model, and you're trying to figure out which parameters you want to use, this is actually a really good idea. This will tell you which parameters actually mean something, or which ones are actually significant in determining an output, compared to ones that are completely random, right? If you throw in a factor that is completely random, and your machine learning model decides to take it and make it worth everything, your model is pretty much useless. You are better off guessing or flipping a coin than trying to have it do all of that processing to get an output that is probably wrong. So with things like this will actually make your life in machine learning so much easier, because it tells you literally which ones are different and which ones are not, and which ones are critical in determining the output and which ones aren't. So the reason we decided to pick this topic instead of just machine learning is I think a lot of different groups are doing machine learning. So we said, okay, we'll teach you something that's important that will help you make better models than someone without this knowledge. So hopefully this was helpful. Thank you for your time, and good luck with the hackathon.
here's just the basic HTML structure. As you can see, all the code is written between two HTML tags at the top and bottom. And there's also a head tag and a body tag, which also just adds to the structure. And there's also some elements. As you can see, there's a title element that just defines the title for the tab, and it has both the starting and end tag. The starting is just title, and then the end tag is just the same thing as the starting tag except with a slash. And there's just multiple tags. So here's just a list of some of the common tags. You have a paragraph tag, which is just a paragraph, and you have headings that go from different sizes, and it starts from heading 1 to heading 6. So here's some tags that can be used on the same line. The bold tag is just bold, can just be used to bold text. The italics is just italics, and I'm sure you guys know like all the what underlining and highlighting. So the break element is one of them that doesn't need an end tag. You can just write BR and then it'll create a break in the website, and there's just a horizontal line too. So here's some more useful HTML. Here's some more useful HTML tags. There's one for a link. It's just A, and then you just put the link in the blank spot, as you can see it like there. And there's an image too. So the image will only work if it can find the file, but if it doesn't find the file, it'll just like put some text up the file. And then there's ordered and unordered lists. They're declared differently, but to create list elements, it's just, you just use li and then like the text. And then you can also write comments in HTML. So here's just some like practice examples of something to do. You guys don't have to do it. You can like just think about like how you would do it, and like we'll show you some possible solutions for these like example problems. So here's some example or solutions. So the first one was asking for a large heading as highlighted and underlined, and the first image is an example of how you would use multiple tags on the same line. You would be using the heading tag, the bolded or the underlined tag, and the highlighted tag on the same line, which would do that. And then the second one is just the paragraph with the horizontal line, and it's just using the paragraph tag and then inserting an HR tag underneath, which would just create a horizontal line. And then the third one is just an unordered list. So you would just put it in between two UL tags and then add LIs for each item. And the last one is just the link, and I'm sure you guys all can do that. Okay, so that was HTML. It's just the basic elements of the website. CSS, as we said before, is just customizing the elements. So there's two ways you can implement CSS into your website. You could either put all your CSS information between like two style tags, or you could create a separate file and link it using the second bullet point. You're just linking a style sheet to your main file. And the changeable properties go in like sections with the same name as a tag, and it changes every single element with that tag. So as you can see, there's an H3 color tag. So all the H3 elements on your website would have the color green. And then the fourth bullet point is just, it's just the syntax for changing the value. And so here's like some of the basic CSS properties. There's more online, but these are the main ones. There's color, which is just color. There's background color, there's font size, font family, which is just the font. Text line, which allows you to shift around the text in the website. There's text decoration, border width, and yeah, just properties. And here's like just a more in-depth guide of like how to call the elements in CSS. You just have the tag, and then you'd have the style property. And you can create classes or IDs. They both work for changing like elements, but like some of them, they have different syntax. One uses a period while the other uses a hashtag. And like here's just an example of both HTML and CSS in the same file. So one of them is defining a class and the other is defining an ID. And then at the bottom you can see they're called slightly differently, but they have the same impact of like affecting how the element is displayed.
Okay, so for adding JavaScript to HTML, there's several ways you can do it. Some of them is using the script tag, which allows you to keep adding on to the HTML file. And you can also add a separate file on it. So for some information about JavaScript, it's mainly used for adding functionality, like we said before. There are other functions and arrays and everything you can add that we'll talk about later. And semicolons are usually preferred, but aren't always necessary. So starting off with if-else statements, they are basically just conditions. You're saying that if a condition is true, then do the following code. If not, if there's any following else ifs, to do that as well. And depending on which condition is true, it's going to keep going down the ladder. So if condition 1 is true, they'll do the first one. And then if not, then they'll go to 2. And then if there's an else, that will always be executed if none of the above conditions are true. Loops are very useful if you want to do a code several times. There's a few different loops you can do. A for loop would allow you to declare a certain variable, a condition, and then also increment that variable. A while loop goes as long as the condition is true, but you would also have to make sure you eventually make the condition false because you don't want an infinite loop. In a do while loop, the difference is it will do something first and then check if the condition is true. So that way, the do while loop will always run at least once. Arrays are very useful for storing information. There's 2 different ways you can do it. You can either set brackets and keep listing the items you want in the array, or you can just say new and then put in the number of elements you want. There's also different properties you can use, such as push add something to the end of the length. It just stores how long the array list is. Sort makes it alphabetical, so the numbers would go first and then alphabetically the rest. And toString just takes everything and turns it into a string. Forms is probably something you might be looking into a bit because it allows you to have more user interaction. So buttons and any sort of like survey information is what you would use this for. In order for the syntax, you would just say label for and then set it into its ID name. And then you would just set in, depending on what you want, you would just say the type of information you want. Functions and on-click. So if you want to ever store a lines of codes that you want to use several times for its functionality, you would use a function. You would declare a function by saying function and then the name of it. And then inside would be any time you want to use that. In order to use that, whatever lines you just created, you would just call the name of the function. The on-click allows you to do something whenever you click something. So if your mouse interacts with a certain element, it should say on click. So like whenever it is clicked, the function will be executed. Game dev we won't get into too much, but basically P5 is .js is just a library that allows you to use and create games. You're allowed to add videos, websites, sounds, whatever makes it more interactive. So this is just the basic P5 setup. This just allows you to add on to your HTML document and allows you to start creating games. The setup is what you would have before the game actually starts. So anything you put in there would already be preloaded before you enter. And then the draw is where you would start adding shapes and backgrounds and everything. And that is it. There are more links that we have because we couldn't go through too much depth in a lot of things. So, do you have something to say?
There's like a lot more in like just HTML, JavaScript, and CSS. So if you search it up, there's like a lot of websites that'll like teach you more information about it. But this was just the basics and like I guess seeing if you have any interest in it.
Oh, we're live right now? Okay. Should I start? Okay, so this is our introduction to competitive programming on behalf of our school's computer science club, Cyberhawks. So, what are the major competitive programming competitions for high schoolers? So first up, we have USACO, and it stands for the United States of America Computing Olympiad. So it has 4 online contests, December, January, March, and February. And in March we have the US Open. So each contest is 4 hours long, and you will be given 3 problems to solve. In USACO, there's 4 levels. There's bronze, silver, gold, and platinum. And the accepted languages for this competition are Python, Java, and C++. So this competition is actually really prestigious, and if you do really well in these competitions, you can be chosen for the International Olympiad in Informatics and the USACO camp.
All right, so next up we have ACSL, which is known as the American Computer Science League. So in this competition, you'll be focusing on topics such as number systems, Boolean algebra, digital electronics, amongst many others. So throughout the year, there's usually around 4 contests. And then after that, you have a finals, which is in near the end of May of every year. And so there's 4 different divisions in this competition. There's the elementary, junior, intermediate, and senior. Our school only usually participates in the intermediate and senior divisions, and each contest is split up into one program, which you're given a total of 72 hours to do from the moment you start until that 72-hour time period ends. And then once you do that, you'll have the opportunity to take a 5-question short answer test that is a total of 30 minutes. And when it comes to the contest program, you get an option using 3 different languages. You get to use Python 3, you get to use Java 8 or C++. They accept any of those. And this competition is usually through HackerRank, so you usually have around 10 different test cases that you need to fulfill. They usually give you around 3 or 4 of those test cases for you to refer to, and the other ones are usually locked in order to make sure they can actually test your knowledge with these programs. Alright, so next up we have a video from a person named William Lin. It's not showing up.
I mean, I saw the video. You just want me to summarize it?
No, it's fine. Oh, you want to try connecting to my computer real quick?
Yeah.
Alright, can you get my computer? We can put it up on the other computer. Alright, can you move your computer out?
Yeah.
Okay. Make sure the audio is connected. Yeah.
You don't know how, or maybe you want to avoid making common mistakes that beginners make. This video will be split into many different parts, depending on where you are. There should be a list of topics with their timestamps to my left. Make sure that you check out the list of mistakes at the end. You might think that the first step would be to learn to program, but that's not exactly the case. If you are going to learn anything online, you'll need to at least be able to understand English. I think that most people are fine with this, but just keep this in mind if English is not your native language and you don't have that much experience with it. The second thing is math. Yes, you do need math to do CS, which might make some of us a bit uncomfortable, but don't worry, most of it can be learned along the way. You need a math level equivalent to that of a typical student in the US from grades 8 to 10, and mostly just the algebra and combinatorics, which means you can forget about geometry, trigonometry, and calculus. You also need to know very basic modular arithmetic and number theory. CS contains a lot of graph theory, but you don't need to know about it when you start. If you happen to have experience with math contests like math counts, AMC, or even Olympiads, then you're off to a great start already, and you don't need to worry that much about this. If you feel like you might need a bit of review on these topics, you can go to the math section on HackerRank, where you can do problems on number theory, combinatorics, algebra, and probability. You don't need to finish all of the problems, just make sure that you know the basics. The last thing is touch typing. Touch typing is where you type without looking at your keyboard, and it can greatly boost your typing speed. You basically use the home row position and you memorize where all the keys are. My typing speeds without touch typing is 30 to 40 words per minute, while my typing speed with touch typing is 100 to 130 words per minute. If you don't know what touch typing is, be sure to learn it, and one website you can use for this is keybr.com. You don't have to type as fast as I do, but getting to 50 to 60 words per minute would be nice. Now we're at the second step, which is learning a programming language. You might have heard that most top competitive programmers use C++, and that's true. This is because C++ is sometimes necessary for some of the harder problems, as it is one of the fastest languages. However, if you already know a programming language that is not too obscure, then don't bother learning C++ yet. I got to Red on Codeforces, which is the Grandmaster rank, by only using Java, and I only switched to C++ after that. If you don't have any programming experience, there are several options for you. If the idea of writing code really scares you, then you can start out with Scratch, which is a visual programming language. Many kids start out using Scratch before transitioning to writing real code. I recommend most people to just start learning C++. There's a nice 9-hour video on the basics of C++. I'll include the link in the description, and I recommend you to watch and learn the first 5 or 6 hours of that video. After you finish that, you can continue by practicing the C++ skill on HackerRank, where there are a bunch of useful problems, and you don't need to finish all of them, just make sure that you know the basics. So you have now learned to program, and you want to start CP in particular. You'll need to start learning basic problem solving, algorithms, and data structures. There are several resources which you can use for this. The first one is the Competitive Programmer's Handbook, and the link will be in the description. It contains many useful concepts and explanations for beginners. The second one is the Algorithms page on Geeks for Geeks. It contains an exhaustive list of articles of the most common algorithms that you will encounter in CP. If you can't learn something in the resources above, you can always use Google to find useful articles on anything that you want to learn. To practice, one good resource which I've mentioned several times already is HackerRank. They have an algorithm section, and you can do all subdomains in this section except for the last two. The problems on HackerRank have good editorials, which are basically explanations for the problems. A question I get a lot is whether there is any roadmap or syllabus for competitive programming. The answer is most people, including me, don't follow any such roadmap. We just do whatever practice we can find. However, if you still want an ordered list of problems to practice from, you can try A2OJ ladders. These ladders contain lists of problems for people of all levels, from beginners to more experienced competitive programmers. Another list is this spreadsheet made by Mustafa Saad, and the link will be in the description. Most of the explanation videos are in Arabic, but the list of problems is still useful. In addition, contests are fun, and doing contests is also a form of practice. If you want to test out your skills, there are a few contests for beginners. The first few problems of LeetCode Weekly contests the first few problems of AdCoder beginner contest, and the first few problems of Codeforce's Division 3 rounds are ones that I would suggest for beginners. I will introduce more contests in CP in more depth in other videos. The last step is just doing constant practice by doing problems and contests. I'll go over this in more detail in another video, so you should definitely subscribe so you'll be notified as soon as that video comes out. Okay, so let's move on. Wait, what's the step? Making a YouTube channel to flex your skills. Just ignore this step. It's just stupid. Who would ever do this? The first common mistake is relying on college courses. Although college courses such as MIT OpenCourseWare do contain good classes to learn algorithms from, the target of their courses is more for CS research than for CP. Problems that you practice in courses will not be the same as problems in CP. The second common mistake is reading too much. Although you do need to learn basic information for CP, CP is about problem solving, and reading is not problem solving. Reading is passive. When you read, your mind is waiting for the answer to appear in front of you, but you want to train your mind to be active and not passive. There's a 5% rule, which states that for every 100 minutes you spend on CP, less than 5 minutes of that should be reading. And this number only decreases as you start to learn most of the basic concepts. The third common mistake kind of goes along with the last common mistake, as if you read too much, you will likely be learning techniques that are too advanced. If I just use the example of data structures, there are many powerful data structures out there like hash maps and segment trees. However, those data structures should only be used when necessary. In coding interviews, the interviewers are probably looking for solutions that use simpler techniques. For CP in general, harder algorithms take more time to implement, make your program slower, and more complicated programs are more likely to fail. The rule is, if you can't solve most problems which require easier techniques, then don't bother learning the harder techniques. The last common mistake is comparing yourself with others. Sometimes I receive complaints from people like, my friend started CP 1 month later than I did. You want to know how to start competitive.
From the video right now, and we're just gonna talk about a few key points and key takeaways from the video. So, competitive programming really utilizes your math and problem-solving skills. Like he said, experience with the AMCs, math counts, and math competitions are really good for this. And C++ is a great programming language for competitive programming, but Python is still very acceptable for beginners. So there's a lot of online resources to learn data structures and algorithms, and HackerRank is a really good resource for competitive programming, like he mentioned, and it's all about speed. So you need to consider your program's runtime complexity, and not only do you want to create an algorithm that can solve the problem efficiently, you want to create one that can basically solve it the fastest. We're looking for an algorithm that works, but can also run in a fast amount of time. Also, practice is perfect, and we're doing this to have fun. So let's solve some problems.
Alright guys, so who's heard of binary search before? Have any, okay, binary search, you want to explain? Binary searches?
I think a binary search is basically rather than going through each element, you basically, if I remember correctly, it finds like the middle element of something and it splits it up and then like it goes into something.
Okay, yeah, that's a pretty good description. The idea with binary search is that instead of doing a linear search that goes through every single element, that's going to take a lot of time. Yeah, that's true. So something to mention is that it's actually only working for sorted arrays, because the idea behind binary search is that instead of going through every element, you're splitting the search space by half every time you make a query. So I'm going to test your math skills here. If every time you make a comparison, you're dividing by 2, how many comparisons are you making before you get one element? A hint is logarithms. Yeah, exactly. It's going to be log base 2 of n. And this is considerably faster than going through every element, which has a runtime complexity of n. Alright. Here, you want to go? Oh yeah. Okay, this isn't a problem. Let's go to the next one. So we're going to go through some sample problems involving binary search. I'm going to give you around 5 minutes to solve the first problem up here, which is 2-sum. All right? And then at the end, we're going to take some ideas about how you can solve it using binary search.
Okay guys, any ideas on how to solve this using binary search? Okay.
Okay, if we don't have any ideas with binary search, how can we solve this with brute force? What would be a naive solution to finding every single pair that sums to 19? Any ideas? Are we have an idea? Yeah, exactly. So that's the naive solution because it has a runtime of around n squared, and that is not exactly efficient. Now, Haley will explain how we can use binary search to solve this in a more efficient way.
So here we're looking for an algorithm that's going to work every single time. Because we're looking to make them add up to 19, what we can do is traverse every single element in the array or list, and we can subtract that from 19 and see if that other element also exists. If 19 minus 2 or 17 also exists in the array, then 2 and 17 will become a pair. Is that correct? So we can use binary search to do that, and using that approach, we find 3 pairs. So we have 3 and 16 because 3 over there, 16, and they add to 19. Even using our algorithm, 2 won't work because there's no 17. 4 won't work because there's no 15, and 7 won't work because there's no 12. Just like that, we get 3, 16, 9, 10, and 8, and 11.
That makes sense. Any questions so far? Alright.
So next, we're talking about merging some intervals. So how can we merge these intervals so that none of these intervals can overlap each other? I mean, if we consider them to be similar to a number line, I think that's a lot easier.
You guys want time to think about it? Okay. We're going to give you like 2 or so minutes to think about it.
How do you think we should solve this problem?
So I think that you should check the lower bound of the integrals, and if the lower bound of one integral is greater than the upper bound of another integral, then they can merge.
Okay, yeah, that's absolutely correct. Because if we have a number line, the first two intervals will definitely merge, but the last two will stay independent, and that's why we can use binary search to solve this problem. Just like that.
Okay, great. So now we're going to talk about a really powerful algorithm called dynamic programming. And this is a very brief introduction to dynamic programming because there's a lot of different types of dynamic programming that can be very versatile, can have different components. And for now, we're going to start with this little example. If I know that a sum of a series, and I don't know all the numbers in this series, so if all I know is that the sum of these numbers is 1491029, how can I find the sum of those numbers plus 10? Does anyone know the answer to this? Yes? Exactly. So this is very simple for us because we remembered the answer to that sum and we just added 10. And that's the very simple idea behind DP. It would take a lot of time to manually sum all of those numbers again. And DP is basically, well, if we already know the sum, we don't have to recalculate that again. We are being efficient by remembering that value and avoiding extra operations. Does that make sense? All right. Okay, have you guys heard the Fibonacci sequence? I'm sure you have. All right, so something we might want to do is calculate the nth term of the Fibonacci sequence. And what you might do is say, well, if I want to calculate the fifth term, it's the sum. Oh yeah, let's briefly go over what the Fibonacci sequence is. It's basically just for every term you're taking the sum of the two previous terms. So if I start with 0 and 1, what's the next term going to be? 1. And then 2, 3, 5, 8, and so on. So if I want to calculate the nth term, and we did it recursively, so for example, if I take the fifth term and I did f sub 4 and f sub 3, and then I kept going, that would be very inefficient. And we'll show you why in the next slide. All right, so look at this tree over here. This is clearly not efficient because how many operations are we making here? 2 to the n, right? And that's not good because our program will run for a very long time. But if we use the power of DP, we can make this go a lot faster. We can make it go in linear time, basically. And Haley actually has a code. Let's see, can we show the code? Yeah. Yeah, so let's show you a brief code about how we can use DP to make this more efficient. All right, well, the idea is that if we calculate the fourth term, do we have to calculate it again? No, right? So we can store the values for all the terms that we get. And we can keep these so that we can calculate any further term in linear time, in O of n time. And here's the code. You want to walk through it?
So this code prints the first 5 terms of a Fibonacci sequence, and what it's doing right now is if n is 1 and n is 2, those are base cases because those two terms do not have any 2 preceding terms, and because of that, we need to set our base cases respectively to 0 and 1, and from there, we set a variable to the sum of the previous 2 terms, and then we kind of like switch everything over. Like we move everything, we increment it to the next term, and that's how we keep finding the sum. So here we're just printing the Fibonacci of the first 5 terms of the sequence.
Right, and the values check out. All right, we can move on. All right, so that concludes the learning section of today. We taught you two very useful algorithms for competitive programming. Oh. All right, so now we're going to talk more about, why would you want to do competitive programming? Because it might seem daunting, it might seem like there's a lot of algorithms to learn, but in reality it's very fun. And to prove this to you, I have some popular games that you might have played before. Have you guys played this color sort game? Any phone before? Have you guys? All right. So actually, the 2024 silver contest had a problem that was modeled off of the color sort game. And similarly, 2048, which I'm sure you all have played 2048, and a recent problem also was, well, not recent, 2016 problem was modeled off of 2048. Same with BlockBlast, Slither.io. There's a lot of different problems that have sort of been based off of these, which is why Yusuko is so fun and engaging. Because problem solving ultimately is a game. It's fun and it really requires creative thinking to solve these problems. It's not straightforward programming or math. And I'm going to talk a bit about my experiences programming. I started in middle school, and I was very scared at first because these problems aren't really something you'll see in school. They're not straightforward. You apply a certain strategy. You have to be creative about what you use. And I started to use a lot of online resources, like William Lin mentioned in this video. And as I did a lot of practice, I started to get better. I started to develop muscle memory. And eventually, I was able to solve harder and harder problems. I was able to solve useful problems. And and CyberHawks, which I think we discussed earlier, we do both USICO and ACSL, so you should definitely join if you're interested in developing your skills and becoming a better programmer.
Any closing remarks?
Okay, thank you all for being here, and we definitely look forward to any of you who are interested in competitive programming for CyberHawks next year. Thank you.
teams that make up our team, and then we're going to split into 3 groups for covering different topics. On the programming team, we'll be covering teachable machine, which is basically a machine learning subsystem that uses object recognition. It's very easy to integrate into an existing web app, just like a no-code machine learning solution. And then on the mechanical team and the electrical team, we'll be covering topics like CAD, like 3D design, as well as like Arduino electronics.
Is it? Do you want to change to the workshop? I don't need the mic, right? I mean, I have the lav on right now, but I don't need the handheld mic, right? Do I need it? I don't know. No. Yeah. It's there. I don't know. Do I? I thought this is the one that goes to the stream though, right? I'll turn it on. Okay.
Don't turn this way.
Just stay straight. Cool. Are we live? Troy, are we live? Okay. All right. Hello. Hello, everybody. Hello. Okay. Hello, everybody. My name is Krishan. I am one of the build presidents for the JPS robotics team. So, who are we? Like, what is the JPS robotics team? So we are a high school robotics club, as I was saying, and we're part of the first robotics competition. And we, some of our like greatest accomplishments so far is that in 2021, we were one of the 20 semifinalists globally for one of the FRC challenges we had that year out of 900 teams globally. And on top of that, we take pride with our STEM, we have STEM summer programs that focus on Python, CAD, electronics, and etc. And we taught over 4,200 students, so that's something we're really proud of. Now I'm going to be talking something a little about FIRST and what it is. So FIRST is for Inspiration and Recognition of Science and Technology. It is a nonprofit organization that has a few subgroups under it. So it basically split up into 3 or 4 different groups. So you have FIRST Robotics Competition, FIRST Tech Challenge, FIRST LEGO League, and they also have the FIRST Global Competition, which is an Olympic-style event. And on top of that, there are over 100 countries globally that are part of FIRST. So I'm going to be focusing about FRC. However, if you're interested about FLL, FTC, then we have some members who are part of those programs that you can talk with later. So I'm going to be talking more about FRC right now. So what is FRC? FRC is the first robotics competition. This is a competition for high school students, ages grades 9 through 12. And it's basically where student-led teams come together. They have roughly 6 weeks to build a robot. And they try to make the most creative design to solve a problem given to them every year. And this robot is fully built from scratch. You don't have any pre-made parts. You can have kits, but you still have to assemble those kits. And basically, it has a lot of the older students, so you're more involved with power tools, being hands-on, and it's a great experience if you want to learn how you would be using this equipment in a workplace in the future. And we do a lot of community involvement as outreach as well. As we said before, we do the summer outreach programs. We also volunteer at different elementary schools to showcase our robotics to hopefully inspire the next generation. And basically, you can get awards for a numerous amount of things. You can get outreach, animation, imagery, creativity, and etc. So I'll be talking about quickly about our past 4 years and what we made each year. So each year we're given a different challenge. So in this year's challenge, it was Crescendo. So we have our robot in the back. We can show you that later. Last year's, it was Charged Up. It was a different game. Then 2022, it was Infinite Recharge. And in 2021 was where I said we were one of 20 global semifinalists, and we were Visualize, which was an AI-powered to help the visually impaired. So we have 4 main sub-teams in the JPS Robotics Club. We have mechanical, electrical, programming, and operations. So I'll be quickly discussing what is what. So first, Mechanical, they basically are in charge of designing the robot's design. They build the structure of it, and you know, they make the different subsystems that are all put together at the end to make our one cohesive robot. And they learn to the use of power tools and other machinery in the workshop. With electrical, they make our electrical board, which controls our robot. They connect all the mechanical components so they work electrically with motors, and they basically mount all these electrical components onto the robot to make sure that our robot will be able to function. We have a structure, but now we need to make sure we have the proper mobility now. So we use, electrical would use objects like motors, actuators, and even pneumatics, because pneumatics, although air-powered, are controlled via electricity. Now we have programming, which is basically, they're the ones who code the robot. So what they do is we code in Java, and it basically makes all the autonomous systems for our robot that we need to make. We also code some vision systems into our robot if we need to find certain objects. We also, as I was saying, computer vision. We also do tuning with motors, etc. So this is a lot of what you guys are doing here at the hackathon, programming, trying to figure out how to make your project actually move, and with like what variables you want it to work at. You may also use Python for any other smaller features. And operations is our business subteam. So we have operations is equally as big as the other 3 subteams combined. So basically, they help with networking. They help us write their grants for scholarships and applications. They do a lot of outreach, social events. And what they also do is we mentor kids in FLL, which is First Lego League. And on top of that, we also organize and demonstrate organize community events like HackJPS. So that's all I really have. I don't want to go too deep. I want to give some time to the other sub-teams that are here. Most of our robotics team is right here. But we have like a really fun time, over those 6 weeks, a lot of community bonding. So here's just a few photos, going to Taco Bell, on the bus, etc. It's really fun if you want to get involved. All right, that's all I have. All right, and actually now that I'm done, we are going to be splitting you guys up into the different sub-teams. So if you want to learn about programming is going to be live streamed on YouTube. So if any of you want to watch programming, just continue watching. We're going to have mechanical in the back, and electrical is going to be in the right side. So if you wanted to see the robot, head to the back. You can talk with mechanical. Electrical is going to be on the right side, or on your left, and programming is going to stay up here. All right? All right, chat. All right, chat.
All right. Testing. All right, it works. Wait, it's not. What happened? Let's go.
Okay, so this is I'm Aditya Saini. This is Amrit. We're going to be going over an introduction
from the
to
programming team.
Teachable Machine. By the way, me and Amrit are both programming captains on the JP Stevens Robotics team. So what is Teachable Machine? So Teachable Machine is a simple web-based tool, and it allows an ease of access. It makes class of creating machine learning models very simple, right? And it can be used to classify a variety of different things, but mainly we look at images, audio, and poses. And because of the simplistic nature of Teachable Machine, there's no actual written code that you need to do.
So how does Teachable Machine work under the hood? So Teachable Machine uses TensorFlow, specifically the JavaScript library of TensorFlow, and essentially TensorFlow is also written by Google. So yeah, and this means that when you export models from Teachable Machine, you can export them as TensorFlow models and use them under any TensorFlow platform. And yeah, so you can host your models essentially anywhere.
Okay, so here we see a sample of Ruth. We have two classes over here. One where his face is turned away from the camera towards the right, and then another one where he's looking straight at the camera. And then we have about 164 image samples for when the face is turned, and 193 image samples of him facing the camera. And these samples are used in our machine learning to understand how Amrit is looking in the actual webcam when he's either looking straight at the webcam or he's looking away from the webcam. Okay, so let's create a model now.
So before we start creating a model, let's go over some key terms that are important. So first, an epoch. So an epoch basically defines when each sample in your training data set has been fed through the model at least once. And so that's obviously if you define it as one epoch, and if you choose, let's say, 50 epochs, then that means it'll be the checkpoint once your training data set has been sampled like 50 times by the model. And next, training samples are just what is actually used to train the model, like the data, and this is usually around 85% of your data set. And testing samples are what are used to double check the model's performance, and this is about 15% of your training data set.
Okay, so now we want you to head to teachablemachine.withgoogle.com/train, and we're going to be covering some stuff live as well, so you guys can follow along.
No, it won't work on your phone. Okay, so as it loads, we'll give you guys some time to also load up the page. Okay. All right, so you should get to this screen once the website loads. So for today, we'll be training a simple image project. So let's click image project. And for now, we'll just select standard image model. So you can see that there are two classes here. So classes essentially define what you want the model to like differentiate. So for example, if we wanted to create a model that would classify me and Saini, so one class would be me and the other class would be Saini. So that is what we're gonna do right now. So let's edit the class, and we're just gonna name this me, so I'm Ruth. And the next class we'll name Saini. So you can add image samples in any way you want, but for now we're just gonna use a webcam since it's easier. So Saini, do you wanna?
I'll go first.
Yeah, Saini can go first. So he'll go in front of the webcam, and you can feed your training set. So as you can see, he moves his head in all different orientations because you want to increase the accuracy and you want the model to be trained in order to recognize any sort of angle of your face. And so I'll do the same thing as well. So I'll click webcam and yeah, just hold it.
The more image samples you have, the more precise your actual output is going to be.
Alright. So yeah, we both did around 140 to 150 image samples. You can obviously do more, but this should be enough for our use case. And also, you can also edit the amount of epochs and the batch size and the learning rate if you want, but for now we'll just keep it the same. So yeah, we'll just click train. And yeah, this will take some time. But don't turn it off. Wait, why is it taking so long? Oh, yeah. Is the Wi-Fi bad? I did. Look. It's downloading. Alright. Give me. How do you turn it on? So, we're having some technical difficulties training the model. I think it's just bad network. So we'll wait for a couple more minutes, but if not, I have a model which I already trained at home, downloaded, and we'll just use that for the rest of the tutorial. It's not happening. I don't think it's happening. Wait.
I think it's too many image samples.
Doesn't matter. I don't know. I'm not gonna inspect it. Alright, I'll just wait. I'll open a local train. Where's my mouse?
Okay, so we're just going to open a local project then.
Whoa. Alright, just move on. Let's just move on.
Okay, so we're just going to move on now.
No, we trained it ourselves. It's just bad Wi-Fi like in this location, I think. So it's not able to like train. So.
Well, if it's trying to pull data through something, then it's all.
No, we already tried this before. It's just not working here, like in this location. Alright. No. Well, I mean,
Let's just continue with the search.
yeah. Okay, so obviously we weren't able to train it live because of network issues, but if you were to train it, you would get a message asking how you wanted to use the model, and so if you hosted the link on TensorFlow's website, they provide you with a code sample which could be used to test it locally. So this is essentially the code that they provide, and if you put the URL to your model here from the website, it'll essentially load the model and use your webcam, and you can basically run it live on the website. And yeah, so this is what it would look like. So you would have like a webcam view over here, and these were our two samplers when we tested the model before, happy versus sad. And so what the webcam would perceive, it would like do the percent, it would basically print the percent confidence of what it thought it saw. So yeah, that's what happens if you would run your model locally.
Okay, so some takeaways. The Teachable Machine is a very accessible and easy way for anyone to get started in machine learning, even if you don't feel like you have the programming skills to write your own machine learning model. Although it's like geared more towards people that don't have that much experience, there's also a lot of tools and resources that power users can use as well. And there's you can adjust training parameters as well, so that you get higher accuracy with your data.
All right.
Any questions, Simon?
Do you guys have any questions? Any questions? Huh?
I want to see the model.
Say it.
I want to see the model.
You want to see the model? Okay. So let's see. Let's see if I can get it to work again. Reload. So this time I'll just try it with less samples. Yeah. So Saini and Ruth again. All right. Go.
Just tell me when to stop.
Yeah. Yeah, that's enough. All right. Yeah, and I'll try. Yo, tell me when to stop. All right.
Hopefully it should work now with less image samples.
Yeah. Okay, it's training now. And yeah, you can see. Yeah. Okay. So obviously this model's not going to be anywhere as good as what we had before. So yeah. If I tilt it towards me, yeah, it's actually pretty confident that's me. So, Saini, try. Yeah. So yeah, it recognizes Saini. So yeah, I mean.
What if somebody else goes up?
Yeah, sure. So obviously, it's not gonna be. Yeah. So someone come up. Nightshot, come up. Right. Yeah, I think.
Let's see.
Yeah, let's see
who
who
Nightshot looks like.
Yeah. So. So if you don't like. Yeah. Okay. So if you don't like specifically classify like the thing, it'll just like do something random or like what like it thinks a person will look the most like. So I think yeah, okay. Okay, so okay. If we're both in the picture,
it's probably whoever's most prevalent.
It's whoever's most prevalent, yeah. So whoever's like closest to the center. Or like, yeah. Yeah, so right now Saini's in the foreground, so it's him. And then if I step into the foreground, it's more me. Okay? Yeah, so I guess since it worked now, we'll continue with our lesson again. So what we were talking about before. So yeah, you can upload your model, and what it'll do is it'll create a shareable link. So you can either download the model itself and use it. You can host it yourself, or you could, yeah. So it gives you a URL which hosts your model, and it gives you a simple code sample base. So let's go to VS Code, or your preferred code editor. 1 second, let me just open it up. Okay, so now that you have VS Code, let's just create a simple index.html file. And in this, we'll copy paste our code, and we'll go back here and copy paste the URL to our training link. Oh, it's already copy pasted. Okay, so if we open this with a live server, yeah, so it's a sample before, and if you click start, it's gonna basically load our model. It's gonna take some time, but once it loads, we'll have a live demo of what we just saw on that website before. So this is essentially how you would host it locally.
So this code snippet can be used for any of your projects that you might consider doing for HackJPS, especially if you're looking for an AI or ML prize.
Yeah, I think the Wi-Fi is just bad here, so it's not able to like load everything. But yeah, what you saw in the slides before, it would essentially look like this. So over here, you would get a UI similar to this, and yeah, it would have your classifiers. Okay, Any more questions? Yeah.
Can I see if I look more like
Okay. Yeah, sure. Okay. Yeah, sure. Just come over to the camera. Like, look into there.
You look more like a maroon.
Oh, that's crazy. Okay. Okay. Alright. Any other questions? Does anyone have any questions?
Technical questions.
Yeah, like actual technical questions.
What's the optimal number of epochs?
Honestly,
What was the question?
it depends on like how much data you're training, but like usually the default is 50.
It's a
but
logistic curve.
for this data set, honestly, like, okay, so how many pictures we have? 50? Like, I don't think 50 is probably too many epochs. You could probably go lower, but yeah. It depends on how much data you're training.
It's a logistic curve.
Yeah, kind of like a logistic curve. Okay, thank you for listening.
That was so much worse than last year.
Yeah. Dude.
trying to help everyone else have a good time as well. And we donated them some cardboard, and they were able to come up with a whole basically like this and on the fly, right? Because some of their robot broke, and they were just they actually ended up blocking a few shots too. So.
Yeah, no, they actually ended up winning a design award for that. So.
But their initial design wasn't even like that though. Like,
Yeah, their initial design broke down. They switched to this. They became fully defensive instead.
Even if you're not that good in the matches, like your ranking, some teams will still select you because usually there's not many robots that focus on defense, right? Usually a lot of the robots, they want to focus on like offense and try to score as many points as possible. But if this robot is purely focused on defense, then it might be a benefit to a certain alliance because maybe the other two robots on their team, they're super offensive. So.
I was watching your competitions. Why doesn't it move?
Oh, so I think you should ask the program about that. So we have one of our programming captains here. If you guys have questions about it.
Works really well when we have it.
For defensive, if they just did like that, their climbing mechanism, it'd be really fast. Like I feel like it would have been a lot more.
Yeah, so this is mostly for after qualifiers. So after you've qualified for the finals of a regional match,
You have to qualify first.
it's like top 24 teams are selected. But this doesn't work always because you're going to be placed with robots you don't know. They might have problems, they might not be able to shoot, so you can't really take the gamble. But if you're placed with two robots that can fully shoot, they're fully capable, based on your lines for a robot that's fully defensive.
But
So.
the thing is, for at least their original plan was to have an offensive robot, but since it broke down, they had to just make something up on the fly, right? So they're to optimize the robot to be defensive. Then a lot of it was the fact that they're not with like walls on four sides attempting to block any shot that came to shoot, but obviously
They can block them, but if they disable the other robot, it's penalties.
disable
The other
means,
teams get
turns
points.
them off like by causing enough contacts. Like you can get penalties.
Can you like purposely do that though?
Yeah, you can.
You can purposely ram it like
Not to the extent that the other robots shut off.
and not to the extent that other robots can get damaged.
Often you get DQ'd.
Any other ideas you guys want to share? I think you guys are good to go back to your coding then.
Thanks for coming.
Thanks for coming.